Hey, good afternoon, everyone. This is No Smile John with Disruptive Weather. That's right, I said disrupt. And today, what we're going to do is focus on the setup for tomorrow. So today is March 9th, and it is 6:48 p.m. Central Time. And so, again, I'm based in Oklahoma City, so I'm going to focus in on Oklahoma City and the state of Oklahoma, but I'm also going to focus in on the whole severe weather threat across the U.S. tomorrow. So, what I have pulled up here is the Storm Prediction Center's Day 2 convective outlook. And as you can see, they have an enhanced risk down in southwest Texas, running up to almost the Dallas-Fort Worth area, and another enhanced risk or level 3 up here for portions of Missouri, southeast Iowa, Illinois, and Indiana, just south of the Chicago area. Otherwise, we have a broad area of a slight risk as denoted by this yellow and marginal risk in this darker green. So, what are the hazards that the SPC believes are in play for tomorrow? Well, first they have the tornado. They have in southwest Texas, they have a 5% denoted in this brown shaded area. And up in Illinois, Missouri, Iowa, Indiana, they have a 5% and then even a 10% in portions of central Illinois. Both of these two highlighted regions have SIG 1 hatched down here. So that means they're saying there is a chance of significant tornado potential for tomorrow in those two regions. Note in between the two regions, they just have a 2% for tornado. Going ahead and looking at the wind probabilities, they have wind probabilities all the way from Michigan, all and even all the way to parts of western PA, Ohio, all the way down to the Rio Grande. But where they're heavily focused is down near the Rio Grande up to near Dallas, where they have a 30% chance of severe wind in that region and a level 1 on intensity for significant severe straight line wind. Moving on to hail. Similarly, they have a 30% down here where they also have the wind. And then they have a 30% up here in Illinois, Indiana, Missouri. Same area where we saw the tornado probabilities. And you can see the hatched area goes all the way back to Wichita, Kansas, and then again down here in southeast and south central Oklahoma down to the Rio Grande. Again, as you notice, it's two centers, one to the north and one to the south, and here we are right in beautiful Oklahoma with some probabilities, but definitely not in the highlighted zone. So let's go ahead and take a look and see why that might be the case, or maybe if we see anything else that might be of interest that might say, hey, John, maybe you should go chase tomorrow. So as I mentioned in uh, previous videos, I like to look at the 300 millibar first, which is again about 10 to 12 kilometers up. And as you can see, we have a very strong jet up here to the north, but then you have this break off, cutoff, almost a cutoff low down here to the southwest in just on the Arizona, New Mexico, Mexico border intersection. And you have strong flow coming up over West Texas into Oklahoma, Kansas, Missouri, and then connecting up to the northern jet. This is for 1 p.m. tomorrow. As we go forward, this is 4 p.m. And then 7 p.m. Now you can see that strong flow has really taken a position over the southern plains. And it's even starting to strengthen up here in that enhanced area in Illinois, Missouri, Iowa. Similar to the system from last week, this is another positive tilt system. Positive tilt systems, as a storm chaser, not the biggest fan. If you are looking for less of an impact, less disruption, this is probably more favorable for lower end severe weather. Not to say they can't do it, but just statistically, positive tilts are not as favorable as a negative tilt when it comes to big severe weather events. So just something to keep in mind. And then we'll go through the evening hours, and you can see that it looks like the winds have slowed down up here in Oklahoma. That might be due to storms. So what happens is the storms go all the way up to 50,000 feet or so. And these winds start to encounter that air that's come up from the surface that's not moving with the mean wind. And so this wind up here has to go around the thunderstorm. And that's why you get slower winds where the storms can be. And then this takes us to 1 a.m. One thing to note here, a lot of difluence over Oklahoma at this time. That's I would speculate that that's most likely due to thunderstorms causing the air to have to go around the storms. But we'll find out. So moving down, 500 millibars. Let's go back to 1 p.m. You can see very strong flow again. And similarly to up around 300 millibars, um, we have strong flow in this region coming up over Oklahoma, southeast Oklahoma in this case, and West Texas. Almost all of Texas is in strong flow except for the far western edge. And then we're going to go down to about a kilometer and a half above the ground at 850. So this is the critical level that I usually look at again for tornadoes. And as you can see here, it does strengthen over Texas and Oklahoma by 7 p.m. Just kind of take you earlier in the day. And then we will go to the surface. And as you can see here, you have good southerly flow, 15 knots coming up out of the Gulf of Mexico. A good wide area of the Gulf is all feeding up into the southern plains, so that can transport the moisture up here. 27-hour, you can see strong 15 to 20 knot flow or close to 20 mile an hour. And same thing at 7 p.m. And then this is after dark at about 10 p.m. You can start to see the winds go down a little bit. These blobs of blue, those may be storms. We don't know. They may be, they may not be. I'm just guessing at this point because I haven't seen. I'm looking at this as I go. So next thing we want to look at is moisture. So we want to know if we have dew points that are favorable to develop storms. So first off, what I'm going to do is I'm going to pull up the Southern Plains surface observations as it stands right now. Okay. So what we see here is the red numbers, that's the air temperature. The green numbers, that's the dew point. So what you can see here, you see some mid 60 dew points, even some upper 60s to near 70 dew points along the Gulf Coast. So really good moisture for early to mid March. Even have some 65, 68 dew points right here in southeast Oklahoma. But you get up into Oklahoma City and Kansas, basically right about here and west, You have some 30 dew points in 40s and some low 50s. Not as favorable for severe weather. Um, there have been some cases of tornadoes in around 50 degrees dew point, but you really want this above 60 for early March. Um, so that's kind of what we're looking at. You have highs in the 80s and 70s. We got to, I think, 88 here in Oklahoma City today, so really warm for early March. So what I'm going to do now is I'm going to go ahead and look at what we're currently at. It's actually 7 p.m. on the dot. So we are going to look at 7 p.m. on the dot in the model to see what it was forecasting for this time. So 0Z is 7 p.m. now that we've had daylight savings this past weekend. So as you can see here, you got that good moisture we were looking at in Texas, and you can see that boundary right there where the moisture really drops off to the northwest, right around and southeast of Oklahoma City. Basically, I-44 and south and east has good moisture. So I-44 goes up through this area. It might go a little bit north of I-44, as we saw in eastern Kansas on this map. We go back there, you can see 61, 62. So you can see 60 dew points in far southeast Kansas as well. Okay, so you can see the moisture. Let's see how it progresses with time. Can see there the moisture really gets going further north. We now have upper 60 dew points into Oklahoma City. Let's fast forward to 7 a.m. And what you can see is the moisture really hasn't progressed much further north and west from what it was at 1 a.m. Wichita is right on the boundary where you're dropping off in moisture to the north and west. And you can see this good southerly flow coming out of the Gulf. So it looks like it's setting up to be potentially a pretty good moisture setup for Oklahoma, Texas, even all the way up into Indiana and Illinois, like we were talking earlier on the SPC. So they got good moisture even up to Chicago here. That's pretty far north. I don't know if you saw it last week. Michigan had a pretty substantial tornado with the lake in the foreground still frozen. So that was pretty remarkable to see. That was definitely a disruptive tornado, especially for people in Michigan that are still thinking, hey, it's winter. So I said disruptive. Okay. So again, this is 7 a.m. tomorrow. Let's go to about 10 a.m. Can see still the moisture really hasn't progressed further west. It hasn't shifted at all. It's pretty much steady state here. Still good moisture all the way up here. You still have some 65. That's the 65 dew point coming up in Illinois. Go forward to 12Z or no, 18Z or 1 p.m. You can still see good moisture. Still pretty good moisture. One thing to notice here at 4 p.m. is this little reduction in moisture sticking in Northwest Texas. Not sure what that's about, um, but we'll take a look at it here and see what we get. Yeah, it starts to, you can see it even going up into Oklahoma by 7 p.m. So, I mean, it's above 60, so, we're still above 60 dew point, but I'd like to see upper 60s given what the rest of uh, this warm sector here has in it. So that might have a roll in tomorrow and we'll see what happens. So what we'll do is we're gonna go to 7 a.m. tomorrow to take a look and see what the instability is. So I'm not gonna go into what this is measuring other than it's just a measure for instability. So everything that's green is at least 750, which is sufficient for supercells and tornadoes and severe weather. So everything above green is looking pretty good. You got a little bit of higher pockets above 2000 here. That's definitely more than sufficient. And this is in the morning at 7 a.m. So we haven't even had daytime heating yet. Let's go forward to 1 p.m. What you can see here is you got really a good increase in the instability up here in central and north central Oklahoma into northeast Oklahoma and especially in Missouri, or as I sometimes say, Misery. Wichita Falls, West Texas, looking good. Wow, it's really getting good up here in Oklahoma, Missouri, Illinois. Some Everything I'm seeing is looking pretty good there. Down here, it's actually a minima in Northwest Texas. Not sure. We saw that earlier. And interestingly enough, you can see that minima shift north. So it looks like there's a connection between the instability and those lower dew points we were seeing on the previous map. And then going after dark, you expect it to start declining. One thing you notice here, though, is Illinois is just got really good instability from 4 p.m. on. So they're looking really prime up there. Okay. So the last thing that I want to look at is 0 to 1 helicity, which again, that's just a parameter that we look at for strong tornado potential. So as you can see here, everything in yellow and greater is 100 plus. Again, from a previous video in the Central Plains, we look for values around at least 100 and sometimes up to 150. Over here, it's more common that you see the 200 values with strong tornadoes. That may just be because whenever there's a setup, they just have higher values all the time over further east than we do in the plains. So we'll go forward. What you can see is still really above 100 values here in Oklahoma, so looking pretty good in Oklahoma on this model. Up in Illinois, a little bit lower. You got higher ones in Missouri over the St. Louis area and through southern Illinois. So we'll see if that changes as we go later to 7 p.m. So at 7 p.m., you can definitely see that has increased tremendously in central Illinois. It's up around 200 right there. And again, I think 150 is more than sufficient there. Similarly in Oklahoma, almost this whole warm sector area is sufficient. So you could get strong tornadoes anywhere in here with this shear that we look for in the lowest 1 kilometer. Now, the last thing we're going to look at in the model is precipitation. And so maybe precipitation might tell us more about what's happening and where maybe storms are breaking out. So we're going to start at 7 a.m. tomorrow. And I'm just going to look at the 3 hours. So what this is a measure of how much precip is forecast to fall over an area in the previous 3 hours from the time shown here. So at 7 a.m., there's not much precip going on in the warm sector, maybe a little bit of drizzle and stuff, but it's spotty at best. At 10 a.m., we got a little bit more down here by the Rio Grande, but again, for the most part, not much precip happening. By 1 p.m., okay, we start to see what was in down by the Rio Grande is still there, and it looks like it's expanded north and eastward. So you got precip falling in this area and still falling in that area, as you can see here at 4 p.m. And then that area right here still is persisting, but now you have a new area out west. This is likely on the dry line. And so one potential that's happening here is this precip stays stationary in this region for a while. So all that moisture that's coming up here into Oklahoma and Northwest Texas may be getting utilized by these storms in this region. And so if this is a big, as I like to call it, a BFM, so it's a big F mess. Okay, I'll tell you what it is. A big fun mess. I'll say what the F stands for, fun. So it's a big fun mess. And so all this moisture comes up here, and instead of going further north, it gets lifted and precipitated out in these storms. And so then you have a void in moisture behind these storms. That's what I speculate is going on in this model run. So what we're going to do is actually go take a look at a high res model run to make sure we're assessing that correctly in multiple different models. So what I'm going to do is go look at this model run called the HER. Let's see, how far out does it go? 21Z tomorrow. Or no, that's 15Z. So let's go to the 18Z. It goes out a little bit further. So first thing we want to check out is tomorrow morning. And I'm just going to go straight to the precip and look at the previous 1 hour of precip because this one does it in 1 and 6 hour. Um, let's go forward 3 hours. So this is 10 a.m. That's 1 p.m. You can start to see some precip down here in Texas. Let's go 1 hour forward. Still see precip in Northwest Texas. So it's a little bit might be a little bit further west than the other model we were looking at, but then you can see more precip right here in north central Texas. And then you can see it right here, a couple more spots there. Now, one thing that's interesting is it doesn't look very widespread. It looks kind of more spotty. If it's spotty in nature, that could be supercell thunderstorms going on down here. Supercell meaning a rotating thunderstorm. And if that's the case, that's very ominous looking for Texas. I'm just going to go forward. I'm also taking a look up in the Illinois region. You can kind of see spots of precip there as well. What I'm going to do is just zoom in to some of these locations. And you can see right there the precip. I'm going to see if there's any updraft rotation. So rotating storms in this. So what this is the updraft rotation parameter that we look at. And it says any updraft rotation that's occurred from the beginning of the model run through this time. And you can see you do have some spots there with um, updraft rotation. And we'll take it all the way through the whole end of the period. Wow, look at that one. But you can see there's a lot of updraft rotation occurring in that zone. And we'll go forward through the full model run. But you can see it's kind of not doing much in central Oklahoma. Let's go see what this model says for instability in central Oklahoma. So we're going to look at 1 p.m. tomorrow. So we have instability at that time. But as you can see, you see storms here. That those little minimas are probably storms in the instability field. It looks like the instability just drops off north of those storms, and you can see that right here, and that seems to be what's going on. It's as if a big bird came through and just dropped a big turd of dry air over this region. And That is not very good if you're wanting to go storm chasing up here. And you can just see how it gets bigger and bigger and bigger. And I bet you'll see it here in the dew point map now. Oh yeah, 49 dew point in Oklahoma City. So you can see the better moisture is confined down here. So that's why they're not very big on, that might be why they're not very big on Oklahoma. Let's just take another look at another couple models here and see what they're doing. These are some more models. That one still has good moisture by 7 p.m. 65. It keeps it confined to more southwest Oklahoma, but it doesn't have really any storms in our area up here in Oklahoma. Let's go to another one. See, now I'm kind of cherry picking to see if I can find a model that gives me something to chase. This one kind of has something there, but it's in low dew point air at that time. Um, yeah, this isn't impressive at all. It's like the storms in Texas just vomit dry air out after they use up the rain, the moisture here. So that's disgusting for storm chasing. That's great if you don't want tornadoes in your area. So um, just want to clarify what's disgusting and what's good. Basically, we don't see much in the way of disruptive weather over this area. Okay, now let's shift our focus a little bit more up to Illinois. So let's go back to 24 hour. There's 24. So that's 7 a.m. tomorrow. That's 1 p.m. That's no, that was 10 a.m. This is 1 p.m. This is 4 p.m. and this is 7 p.m. and then this is 10 p.m. So let's just see what we can find in this area. I'm just going to go right to 10 p.m. and I'm just going to say, okay, let's see if there's any helicity in that area. As you can see here, there is a helicity. I'm using big words here, sorry. Updraft rotation in this area. You can also see some other updraft rotation back here in Missouri and Kansas. So, and a little bit of north central Oklahoma. So maybe up there might be a chase. And Michigan, kind of interesting. So again, early March up in this area, not climatologically normal. So that all being said, I think up here could get it done based on what I'm seeing. And so I agree with the SPC, the Storm Prediction Center, having an enhanced risk in this vicinity. And let's go see what the one we had earlier had. Yeah, it has helicity tracks there as well on the HER model. Um, just to kind of get an idea. That one doesn't have as much. How about this one? Yeah, that one doesn't have much either. Uh, and let's see if we have anything on this one. Okay, that's the one we looked at earlier. Okay. So overall, I agree with the risk that they have here for even the potential for strong tornadoes. And down in southwest Texas, I could see that ending up being more of like a squall line. You could still have some tornadoes. You saw some updraft helicity or updraft rotation in the model. So those could be tornado producers, but I think the better probabilities that they have highlighted definitely are up in Illinois. So people in Illinois, watch out. There could be some disruptive weather hat coming your way tomorrow and tomorrow evening. And it looks like it could have the potential to occur right around sunset or right after sunset. So it could be after dark, which we know is very dangerous as well. Anyway, thank you for joining today on Disruptive Weather. Again, I'm No Smile John. Please like this video if you liked what I presented today, and please subscribe to my channel. Thank you, and have a great day.